Let me graph the function y equal cosine x. Now I'm going to assume when certain x value, the y the cosine x value. And so when x equals 0, cosine 0 is 1. When x equals pi over 2, 90 degree, cosine pi over 2 is 0. When x equals pi, cosine pi is negative 1. When x equals 3 pi over 2, cosine 3 pi over 2 is 0. And cosine 2 pi, when x equals 2 pi, cosine 2 pi is back to 1. So you use this to graph y equal cosine x. Here I gave x and y axis. So when x equals 0, that is 0, y equal 1. When x equals pi over 2, y equals 0. And this is 1, 0, 1. When x equals pi, cosine pi is negative 1. When x equals 3 pi over 2, cosine 3 pi over 2 is 0. When x equals 2 pi, cosine 2 pi is 1. So use this basic 5-point. You can graph the cosine functions 1 period. And so this 1 period is repeating every 2 pi, to the left infinitely and to the right infinitely. So here I'm going to state the period is equal to 2 pi. Since it goes up by 1 and down by 1, that one value is called amplitude, which is 1. And now, so you want to keep this 5 essential point in mind to graph any other graph with different coefficients. Now, if you're graphing y equal a cosine bx, but I will have to explain that with one example. And so if you're graphing y equal 4 cosine 3x, here 3 will change the period. So 3 will change the period from 2 pi divided by 3. The coefficient of x changes the period. Here the 4, a value, will change the amplitude. So the amplitude, instead of a, amplitude is now 4. So if you remember x value and a y value of y equals 4 cosine x. So the angle, if you didn't have a 4 and cosine 3, so you would have a cosine x value. So 0, pi over 2, pi, 3 pi over 2, 2 pi. That was the original value for the cosine x. When you have cosine 3x, that will change each of this x value divided by 3. So 0 divided by 3 will be just 0. Pi over 2 divided by 3 is the same as multiplied by 1/3, which is pi over 6. Pi divided by 3 and divided by 3 is multiplied by 1/3. So this becomes pi over 2 and 2 pi divided by 3. And then y value is, since changing the amplitude, it's a 1 times 4. And then 0 times 4 is 0. And then negative 1 times 4 is a negative 4. And 0 and a 4. So now if I graph y equals 4 cosine 3x with a change in the period of 2 pi over 3 and amplitude 4, and so you would mark this value. Period is now 2 pi divided by 3. 3 because there's a coefficient 3x. And then half of that is pi over 3. That's pi divided by 3. And then pi over 2 divided by 3, which is pi over 6. 3 pi over 2 divided by 3 is pi over 2. And so these are the, and of course 0 is the first x value. When x equals 0, 4 times cosine 0 is 4. And 0 times 0. And then pi over 3 is negative 1 times 4, which is negative 4. Pi over 2, 0. 2 pi over 3, 4. So the graph of 4 times cosine 3x will look like this. So don't forget, coefficient of x, b, will change the period to 2 pi divided by b. And so if b is 3, 2 pi divided by 3. Now a coefficient, absolute value of a, is going to be your amplitude. So that will be your period, and that will be your amplitude for any other examples. So what I draw is the graph of y equal 4 times cosine 3x. Now this graph is a shifting graph from the y equal 4 cosine x. And this is a shifting to the right, but you're not shifting to the right by pi over 2. To know how much you're shifting, you must factor 3 out. So 4 cosine 3, and then x minus pi over 6. And so when you're factoring 3 out, one thing you can do is that you multiply 3 top and 3 on the bottom, and then factor 3 out, and 3 times 2, 6 in the denominator. So pi over 6. This is the graph shifted. The graph of this one is shifted this y equal 4 cosine 3x to the right by pi over 6. So each of this x value is shifting to the right by pi over 6. So 0 plus pi over 6. The second point was pi over 6 plus pi over 6. Third point, pi over 3 plus pi over 6. And then pi over 2 plus pi over 6. And then 2 pi over 3 plus pi over 6. And these are the new x value. And the y value doesn't change, so it'll be 4, 0, negative 4, 0, 4. And so we are shifting each point to the right by pi over 6. So the first point will be pi over 6, and that will correspond to 4. And pi over 6 plus pi over 6, which is 2 pi over 6, which is pi over 3. So that pi is pi over 3, which is pi over 6. This one right here is 2 pi over 6, 2 pi over 6, which is pi over 3. That's when it is 0. And then pi over 3 plus pi over 6, which is 3 pi over 6, and now it's pi over 2. Pi over 2 will correspond to negative 4. And pi over 2 plus pi over 6 is 3 pi over 6 plus pi over 6, which is 4 pi over 6. And this, if you reduce it, that's 2 pi over 3. That you will have a 0. And 2 pi over 3 plus pi over 6, which is 5 pi over 6. And that's when it's a positive 4. So shifted graph will look like this, to the right by pi over 6. So this one is the graph shifted. So this graph shifted to the right, shifted to the right by pi over 6. And now if you're trying to graph 4, now from this graph, I am going to show you how to graph y equal 4 secant 3x minus pi over 2. This is the graph you need to graph first, y equal 4 times cosine 3x minus pi over 2, which I showed you already how to graph above right here. So it is a shifted graph from the graph of y equal 4 cosine 3x to the right by pi over 6. Now keep in mind that this graph will help graph for secant 3x minus pi over 2. So from here, since the secant x is 1 over cosine x, whenever cosine is 0, secant x will have a vertical asymptote. So from this one, you may do the two vertical asymptote at the part where cosine is 0. This line is the vertical asymptote for the second function, and equation of this vertical line is x equal pi over 3. And now when cosine is 0, secant is vertical asymptote, so I'm drawing another vertical asymptote for the second function. And now this line right here is x equal to pi over 3 will be the vertical asymptote for the second function. Now when cosine is 4, cosine value, 4 cosine 3x minus pi over 2 value is 4, and secant will have the value 4 as well. So this will be shared point. And graph of secant is inverted graph of this one with the vertical asymptote x equal pi over 3. Now this is a shared point, pi over 2 and negative 4. And keep in mind the vertical asymptote of x pi over 3 and x equal to pi over 3, and you invert the graph of cosine function and to make it approach the vertical asymptote. And this point right here is 5 pi over 6 and 4 share the point with the cosine function, and this point will be on the second function, 4 secant 3x minus pi over 2, and inverted the graph so that it has a vertical asymptote as x equal to pi over 3. So the green one is the graph of y equal 4 secant 3x minus pi over 2. Now I'm going to erase the graph of cosine to indicate that green one is the graph of y equal 4 secant 3x minus pi over 2. And so when cosine was 0, secant will have a vertical asymptote. And that's why the line x equal pi over 3 is the vertical asymptote for the second function. Another vertical asymptote is x equal 2 pi over 3. And that's the vertical asymptote for the second function because that's where the cosine was 0. So the green one is the one period of 4 secant 3x minus pi over 2.